information in the memory of the quantum computer safely, robust.
Quantum computing and black hole physics are closely connected. Scientists can calculate how much information a black hole can store, revealing deep mysteries about the universe. Famous physicist Brian Cox recently said that a new discovery in quantum computing gives us a glimpse into a reality so strange that it changes how we understand everything. Technology is advancing faster than ever, and discoveries in fields like quantum computing are changing the world. Google, a leader in this area, has created a new quantum chip that has broken all previous records, achieving things once thought possible only in science fiction. But this is not just about technology. It has huge effects on security, privacy, and even our understanding of reality. To understand why quantum computing is so important, we need to know how it works. Regular computers use bits, which are either a 1 or a 0. Every digital device, from smartphones to supercomputers, relies on this system. But quantum computers use qubits, which can be both 1 and 0 at the same time due to a concept called superposition. When qubits become entangled, they connect in a way that allows them to work together instantly, no matter how far apart they are. This lets quantum computers solve problems much faster than regular computers. This technology could transform industries like medicine, finance, and artificial intelligence. Quantum computers could help discover new medicines or optimize complex systems in ways that classical computers never could. However, Brian Cox warns that this power comes with dangers. Quantum computers could break modern encryption, which keeps our data safe online. Right now, security systems rely on math problems that regular computers take centuries to solve. But a quantum computer could break these codes in seconds, making personal, financial, and government data vulnerable. Google's new quantum chip is a huge leap forward. Earlier quantum computers struggled because they could only use a small number of qubits effectively. Errors and instability were big problems. But Google's latest chip has overcome many of these issues, making quantum computers more stable and powerful than experts thought possible. One of the biggest concerns is cybersecurity. Encryption methods like RSA and AES protect emails, banking transactions, and government communications by using extremely difficult math problems. A quantum computer could break these codes almost instantly, creating serious risks for online security. But the impact of quantum computing goes far beyond security. It could change the way we understand reality itself. Quantum mechanics itself challenges how we understand reality. Fundamental ideas like superposition, entanglement, and the observer effect, which were once only theoretical, are now the foundation of how quantum computers work. By using these ideas, we are interacting with the very fabric of the universe. But this leads to unsettling questions. One of the most thought-provoking ideas is that quantum computers might one day be able to simulate reality itself. Scientists believe that powerful quantum systems could create highly detailed simulations of the universe. This connects to the simulation hypothesis, which asks, if we can create simulations that are identical to reality, how do we know that our own world is not already a simulation? This question, which philosophers and physicists have debated for years, is becoming more relevant as quantum technology improves. The ability to simulate reality could have major consequences. For example, if governments or corporations could create accurate simulations of human behavior, they might predict and even manipulate people and entire societies in ways never seen before. In such a world, privacy, which is already at risk in the digital age, could disappear completely. The ethical concerns surrounding quantum computing are enormous. Who should be allowed to use this powerful technology? How can we make sure it is used responsibly? What protections can stop it from being misused? These are critical questions for policymakers, scientists, and ethicists as we enter the quantum revolution. The development of this new quantum chip is not just a technical achievement, it marks a turning point for humanity. Because it can change cybersecurity, challenge how we see reality, and reshape society, we must think carefully and act quickly to use it wisely. Despite these challenges, quantum computing has incredible potential. If used responsibly, it could lead to a new era of scientific discovery and innovation. For example, quantum computers could completely change our understanding of nature, from how tiny subatomic particles behave to how complex ecosystems function. They could help create breakthroughs in renewable energy, material science, and quantum biology. In medicine, quantum computing could speed up the discovery of new treatments by allowing researchers to simulate molecules with incredible accuracy. This could lead to cures for diseases that have long been impossible to treat. In agriculture, quantum technology could improve food production and supply chains, helping to solve problems like global hunger and food shortages. Quantum computing could also play a major role in space exploration by solving complex equations that describe how celestial bodies move, developing advanced propulsion systems, and even helping humanity reach other star systems. As physicist Brian Cox has pointed out, the challenge is to balance the risks and benefits of this powerful technology. Quantum computing is neither good nor bad. It is simply a tool. Its impact depends on how we choose to use it. To make sure it benefits humanity, we must handle it with responsibility and foresight. This means investing in education and research to train experts in quantum technology, promoting international cooperation to avoid a quantum arms race, and setting ethical rules for its use. It is also important to have open discussions with the public about quantum computing, so people can make informed choices about our shared future. Google's new quantum chip is a reminder that the future is arriving faster than we expected. As we enter this new era, we must face both the benefits and risks of quantum computing with bravery, curiosity, and a commitment to doing what is best for humanity. The choices we make now will shape the future, and the stakes are incredibly high. Quantum computing has the potential for both great benefits and serious dangers, and both come from the same source: its immense computing power, which uses the fundamental laws of the universe. As scientists, engineers, and governments begin to understand the impact of Google's new quantum chip, the focus shifts from celebrating a technological breakthrough to urgently discussing responsibility, ethics, and how we manage the technology we create. For decades, computing has been a barrier to solving big real-world problems like predicting climate change, decoding human DNA, or modeling economies. Traditional computers have struggled to keep up because of their limits. While improvements like GPUs and supercomputers have helped, quantum computing is a complete game-changer. But the same power that allows quantum computers to model biological systems or predict economic trends can also be extremely dangerous if misused. One of the biggest concerns is privacy. Right now, the security of our data depends on encryption methods that classical computers cannot easily break. These systems are built on the assumption that solving certain math problems, like breaking large numbers into prime factors, is nearly impossible. However, quantum computers challenge this idea. Google's new chip shows that quantum technology can surpass the limits that protect our current encryption methods. This has massive consequences. Banks, hospitals, and governments all rely on encryption to keep data safe. If quantum computers break these systems, private financial transactions, medical records, and even government secrets could be exposed. This is not just a theory. The threat is already changing global security strategies. Nations are rushing to create new encryption methods that can resist quantum attacks. While this is a step forward, it will take years to fully implement, leaving a dangerous gap where sensitive information is at risk. If a powerful quantum computer fell into the wrong hands, it could cause economic instability, weaken democratic institutions, and violate privacy on a level never seen before. But privacy is just one issue. The bigger ethical question is whether any one company or government should have the power to access and control most of the world's encrypted information. These deep concerns need immediate attention. Beyond security, quantum computing has huge implications for artificial intelligence, AI. AI is already changing industries by automating tasks, analyzing massive amounts of data, and creating personalized experiences. With quantum computing, AI systems could process data so quickly and accurately that traditional computers could never compete. This means AI could become much smarter, learning and adapting faster than humans can understand. Imagine an AI powered by a quantum processor. It could analyze patterns across billions of data points in milliseconds, predicting events with nearly perfect accuracy. This could revolutionize healthcare by allowing doctors to detect diseases early and create treatments tailored to each patient. However, the same technology could also be used to influence human behavior, predict social trends, or even manipulate elections, raising serious ethical concerns. This also brings up questions about control. With AI enhanced by quantum computing, more and more decisions could be made by machines instead of people. At first, this might seem helpful. Machines do not have human biases or make as many mistakes. But what happens when AI becomes so advanced that even its creators do not fully understand how it works? Who is responsible if an AI system makes a mistake or, even worse, deliberately harms humans? These are the complex questions we must answer as we move into the age of quantum computing. Autonomous quantum-powered systems also bring concerns, especially in military use. Quantum computing could create advanced weapons that make decisions in an instant, without human involvement. These weapons could analyze enemy movements, predict strategies, and react faster than any human general. However, removing humans from life-and-death decisions could lead to wars where outcomes are controlled by algorithms instead of diplomacy or morality. The impact of quantum computing goes beyond AI and cryptography. One of its most important uses is in helping us understand physics and the universe. Quantum computers can simulate quantum systems, revealing knowledge that classical computers cannot. For example, they could help physicists study quantum field theory, which explains particle physics, and explore mysterious concepts like quantum entanglement, the Casimir effect, and the nature of space and time. These discoveries could change our understanding of the universe, but they might also challenge deeply held beliefs about reality. Physicist Brian Cox has pointed out that the philosophical impact is significant. If quantum computers can simulate reality perfectly, what does that mean for our own reality? Could we be living in a simulation created by an advanced civilization with computing power beyond our understanding? This idea, known as the simulation hypothesis, has been debated by scientists and philosophers for a long time. While it is still a theory, advances in quantum computing are bringing it closer to serious scientific study. However, the most immediate impact of quantum computing may be in shifting global power. Throughout history, new technologies, like the steam engine, electricity, and the Internet, have fueled economic growth and changed international politics. Quantum computing could be the next major shift, affecting cybersecurity, economic predictions, and military strategy. Nations that achieve quantum supremacy will have a major advantage. This has already led to a quantum arms race, with countries investing billions in research. This race also raises ethical questions. Will quantum technology benefit all of humanity, or will it only give more power and wealth to a few? Despite its great potential, quantum computing is still in its early stages. Even with Google's powerful new quantum chip, many challenges remain before this technology becomes widely used. One big issue is error correction. Quantum computers are extremely sensitive, and even small changes in temperature or movement can cause errors. Scientists are working on ways to fix these errors, but the problem is not fully solved yet. Another challenge is scalability. While Google's chip is a big step forward, creating large-scale quantum computers with thousands or millions of qubits is still very difficult. It will require new materials, advanced manufacturing, and completely new ways of computing. There is also a concern about sustainability. Quantum computers use a huge amount of energy, both to keep them at extremely low temperatures and to power their complex systems. As the world faces climate change and resource shortages, we must consider the environmental impact of quantum computing. Quantum computing has enormous potential, but to unlock its full benefits, we must carefully manage these challenges. As we move forward, we need to balance innovation with responsibility, ensuring that this technology is used for the greater good. Despite the difficulties, the possible benefits are too great to ignore. If used wisely, quantum computing could help solve humanity's biggest problems, from curing diseases to uncovering the mysteries of the universe. However, to achieve this, we must approach quantum computing with careful planning, ethical responsibility, and a strong commitment to using it for positive change. Physicist Brian Cox's warning about Google's new quantum chip reminds us that while technology can improve our lives, it can also bring major risks. As we enter the quantum era, we must move forward with caution, curiosity, and a dedication to the values that define humanity. The future of quantum computing is still undecided, and its impact will depend on the choices we make today. Will we use this technology to create a better and fairer world, or will we let it increase divisions? The answer is in our hands. Quantum computing is not just an improvement to current technology. It is a completely new way of processing and understanding information. As we explore this groundbreaking innovation, it is important to see how it connects with fields like biology, environmental science, economics, and even our understanding of free will. In biology, quantum computing is already showing great promise. It allows scientists to simulate molecular interactions in incredible detail, something regular computers struggle to do because of the complexity of quantum behavior in molecules. Since quantum computers work based on the same principles as these interactions, they can create highly precise simulations. One of the biggest uses for this is drug discovery. Developing new medicines is expensive and takes a long time, often relying on trial and error. With quantum computing, scientists can simulate how molecules interact with proteins in the human body, dramatically cutting down the time and cost needed to develop life-saving drugs for diseases like cancer, Alzheimer's, and rare genetic disorders. Quantum computing could also change personalized medicine. By analyzing a person's unique genetic code, quantum algorithms could predict how their body would react to different treatments. This would allow doctors to create customized treatment plans that work best for each individual while reducing side effects, transforming healthcare on a deep level. Beyond human biology, quantum computing offers solutions to major environmental problems. Climate change, for example, is extremely complex, involving many interacting factors like carbon levels, ocean currents, and deforestation. Traditional climate models, while helpful, are limited in how well they can capture this complexity. Quantum computers could create highly detailed climate models that include many more variables than classical computers can handle. These advanced models could predict the effects of actions like reforestation or cutting emissions with incredible accuracy. This information would help policymakers make better decisions to fight climate change and adapt to its consequences. Quantum computing could also help develop new materials for renewable energy. Scientists are already using quantum simulations to design better solar panels and batteries. By understanding the quantum properties of materials, they can create solutions that improve energy capture and storage, speeding up the shift to sustainable energy. The economic effects of quantum computing are just as significant. One area that could see a major transformation is financial modeling. The global economy is complex and constantly changing. Traditional economic models rely on simplified assumptions, which can sometimes lead to mistakes. Quantum computers, with their unmatched ability to process data, could create much more accurate economic models. These models could predict market trends with incredible precision, helping investors make better decisions and lowering the risk of financial crises. Governments could also use quantum-powered insights to create better economic policies, promoting sustainable growth and reducing inequality. The possible applications of quantum computing are vast and revolutionary, and its story is only beginning. While there are still big challenges, like fixing errors, making the technology scalable, and ensuring environmental sustainability, the rewards of solving these problems are enormous. With careful planning, responsible leadership, and a focus on fairness, quantum computing could become one of humanity's greatest tools for progress. However, as Uncle Ben famously said, with great power comes great responsibility. The ability to predict and influence markets using quantum-powered financial models raises ethical concerns. Companies with access to these advanced models could gain an unfair advantage over competitors, leading to a dangerous concentration of wealth and power. This is why it is crucial to create ethical rules for using quantum computing, not just in finance, but in all industries. As we have seen, the possibilities of quantum computing are nearly limitless. But as physicist Brian Cox has warned, this great power also comes with serious risks. One of the biggest concerns is how it could disrupt the global balance of power. Throughout history, technological advancements have reshaped world politics. The steam engine and the Industrial Revolution made Britain a dominant power in the 19th century, while nuclear weapons during World War II made the United States and the Soviet Union global superpowers. Now, quantum computing could spark a new arms race, with nations competing for quantum supremacy. The first country to develop large-scale quantum computers could gain a huge advantage in cybersecurity, intelligence gathering, and military strategy. For example, a quantum computer could break encrypted communications in real time, giving its operator a major edge in espionage and counterintelligence. Such abilities could lead to an era of increased mistrust and competition between nations, as each one tries to protect its own interests and stay ahead of its rivals. To reduce these risks, it is very important to create international agreements on how quantum technology should be used. Just like the Nuclear Non-Proliferation Treaty helped stop the spread of nuclear weapons, similar agreements could make sure that quantum computing is used in a responsible way that benefits all of humanity. Beyond its practical uses, quantum computing also raises big questions about the nature of reality itself. Quantum mechanics challenges the way we traditionally understand the universe, introducing strange ideas like superposition and entanglement. These ideas suggest that particles can exist in multiple states at the same time, and that the state of one particle can instantly affect another, even if they are far apart. These strange effects make us question some fundamental ideas. Are we living in a universe where every event is the result of past causes, or is reality based on probabilities? Does simply observing something change its state, as some quantum theories suggest? And if that's true, what does it mean for consciousness and free will? Brian Cox often describes quantum mechanics as a window into the most basic workings of the universe. Quantum computing could help us learn more about these mysteries and even test different interpretations of quantum mechanics, like the many worlds theory. This theory says that every possible outcome of a quantum event happens in a separate, parallel universe. If this is true, it leads to even deeper questions. Are there many versions of ourselves living different lives in other universes? If so, what does that mean for our identity and morality? These are not just philosophical ideas. They could change how we see ourselves and our place in the universe. In addition to changing our understanding of reality, quantum computing also forces us to think about the ethics of new technology. While quantum computers could solve some of humanity's biggest problems, they also come with serious risks. How can we make sure this technology is used responsibly? Who gets to decide how it is developed and used? How do we balance innovation while protecting individual rights and societal values? To answer these questions, global cooperation is necessary. One possible solution is to create a worldwide system to guide the development and use of quantum computing, similar to regulations in other scientific and technological fields. This system could include ethical rules, transparency requirements, and accountability measures to make sure quantum computing benefits everyone. When we think about the effects of quantum computing, it is clear that we are at a turning point. The decisions we make today will shape the future of this technology and its impact on humanity. Will we use quantum computing to create a better and fairer world, or will we let it increase inequality and risks? The answer depends on our ability to handle this new challenge wisely, with careful thinking and a focus on the greater good. Brian Cox's warning about Google's quantum chip is a wake-up call. It reminds us that quantum computing has incredible power, but also comes with great responsibility. It is up to all of us, individuals, governments, and society, to make sure this technology aligns with our values and hopes for the future. The future of quantum computing is still unwritten, and the story of its impact on the world will depend on the choices we make today. Let's make sure it is a story we can be proud of.